something has a remainder of 0. Okay, so when you do this, so let's say we did synthetic division and we got a remainder of 0. It means these 5 things. Number 1, x equals c is a solution, or you might see that word root, of the equation f of x equals 0. So if I plugged it in, it would make the function equal 0. Number 2, when f of x is divided by x minus c, the remainder equals 0. Means the same thing. 3, c is a 0 of the function. C is an x-intercept of the graph, and x minus c is a factor. All of those things are true. Okay. So, example 4, if I told you, if 5 is a 0 of f of x, can you give me 4 equivalent statements that you know are true? Can somebody give me one? What's that one? Okay, you're telling me x minus 5, is that what you are saying, is a factor of f of x. So when we factor it, we would get another factor if we divided them. Something else. What'd you say, Haley? So I'm going to say x equals 5 is a solution of f of x equals 0, or a root. What else is going to happen? What about the graph? 5 is an x-intercept of f of x. So I've addressed this one, this is the one I told you. We listed those two. So the last thing is the division. When f of x is divided by x minus 5, the remainder is 0. Okay, so now we can use these things, ideas, to help us factor polynomials. So what I have graphed below is f of x equals 3x cubed plus 4x squared minus 5x minus 2. Let's assume that on the x-axis there's a scale of 1. What are you noticing? Are you seeing any x-intercepts that you feel are quite clear? Which one? 1 and -2. So according to what we set up here, what we can then do is we can use division to factor those. Okay, so by the way, what I'm guessing is if 1 is a 0, that means x minus 1 is a factor. If -2 is a 0, how would I write that as a factor? X plus 2. And then there's a third one there that I don't know what it is. Okay, so here's how we can use synthetic division to do this. We put the 0 in the box. So I'll start over here, and I'm going to put -2 in the box. and I'm going to put the coefficient. What should our remainder be if we're right?
0.
0, thank you. All right, let's do it. Okay, good. So now, what I have left is, this is 3x squared minus 2x minus 1. So instead of going and putting and trying to do summary statement quite yet, did we just confirm that x plus 2 is a factor? Okay, then let's keep going. Once you've divided it out, you're going to use your quotient, which is this, and now we're going to do the other 0. What's the other 0? 1. So I'm going to put 1 in the box, and I'm going to put 3, negative 2, and negative 1. This was our remainder, so I don't put it in. Okay. So when I divided an x cubed by an x, this was an x squared. Now I took an x squared divided by an x. This is my linear factor. So the way I would write this up here is 3x plus 1. That is in factored form. Can somebody tell me then, what is this 0? If you set 3x plus 1 equal to 0, negative 1/3. Okay. Do you guys have questions so far? You remembering? We're just really tired because it's first hour. Alright. Alright. So then, what if I don't have the graph? And actually, when you know, in the big scheme of the history of math, graphing calculators are a rather new thing. In fact, Juan, Lucas, Luigi, do you use graphing calculators in math? Okay. So we just looked at the graph and we saw what we thought were zeros, right? There is this rational zero theorem, which actually helps us identify zeros. And when I was in school, that was the only thing I had to test zeros. I didn't have a graph. And so it's a pretty important thing, I guess, is what I'm pointing out. You're not going to appreciate it as much because you have a graphing calculator to look. But here's how we find potential zeros. First of all, this is a typo. It says integral. This should be integer coefficient. So integer coefficients means whole numbers and their opposites. So when the polynomial has to have whole number or negative whole number coefficient, then the only possible rational zeros of the function are P over Q. What do P and Q stand for? P is the divisor of the constant term, and if you want to write, the constant term is the last term with no x behind it. And Q is a divisor of the leading coefficient. Leading coefficient would be the first term. So here's how this works. It says list all the possible rational roots P over Q. These are only possibilities. So I'm not telling what they are. I'm going to give the possible ones. So I'm going to list for P, okay, because P goes on top. I am going to list all of the factors of the last term. Let's go to the last term. Whew, good, an easy one. Sometimes there's a lot. and we have to list both the positives and the negatives. What are the factors of 5? So I'm going to write plus or minus 1 and plus or minus 5. Good. Those are going to be my potential numerators. Alright, then I go to Q. Q is the leading coefficient, so it's a 6. And I'm going to list, if I can, in order, all of the factors of 6. Plus or minus 1. How about 2? Plus or minus 2. How about 3? Yes, plus or minus 3. How about 4? No. How about 5? No. 6. Okay. So now so these are the possible denominators. Okay. So now what I do is I write them as fractions. So I go through my whole list, okay, and if I had a 1 on top, the smallest one would be plus or minus 1/6, 1 over 6. Plus or minus 1/3. Plus or minus 1/2. And how about 1 over 1? Okay. Now let's make the 5 on top. Plus or minus 5 over 6. Plus or minus 5 over 3. Plus or minus 5 over 2. And plus or minus 5 over 1. Here's another thing that's helpful about this, because if I'm graphing a picture of my function on the screen, if I know the biggest possible rational zero is 5, then I know that I don't need to zoom out anymore if I've gotten past that and I don't see anymore. Alright, so let's make some guesses. Put it on your graphing calculator, this function. Okay, and I'm going to pause here. So what Luigi and Juan and Lucas and I would have to do, because we wouldn't have a graphing calculator, is we would have to take each of these numbers, 1, 6, plus or minus, and put them in for x. And we would have to check and see if we get a 0. That's what we would have to do without our graphing calculator. I'm not going to make you do that. You're going to use your graphing calculator and we're going to make some educated guesses. Juan?
I don't believe.
No, because you haven't done it yet in your country.
No.
No, what?
With this, division, I take the terms that like the terms that we take for 5, plus minus 1, and then I put it here, and if it's 0, I continue with the coefficient. I don't do fractions.
You'll have to show me later. I'm not sure that it works.
I can understand.
Well, you have to use fractions, because some of them are fractions. Okay, let's take a look at the graph. In fact, some of these ones are fractions. I'm going to do negative 7 to 7 in a second, so if I can see it a little better. Alright, so it looks to me that there's a potential one between 0 and negative 1, and between 0 and 1. It also looks to me 1, 2, 3, 4, 5 that there's one at 5. Okay? So we can plug those three. We have some guesses. What's your guess for this one? What does that look like to you? Because our options for fractions are 6 thirds and halves and 5/6. Does that look like a half? Maybe? Okay. So what we can do then is we would plug in -1/2. If you want to use the table function, I've shown you the table function before. You have to set your table up for ask. And then you can type in whatever you have. I'm going to check -0.5. And what do I see? It's a 0. Okay? So one of my zeros is -1/2. I went to table. It will take whatever is in your y equals, and you can plug in values instead of having to plug it into the equation. It'll plug them in for you. Okay, going back to the graph. What about this one? What did I plug into the? What did I plug into the table? You mean table my setup or the table itself? I don't type anything in. I type in what I was checking. What did I type in here? -0.5. Because I was checking that one. Yep. I'm going to check 5, for instance, because I thought 5 was 1. 5 was also a 0. Yes, Luigi.
I don't know how can I plug in number.
Go to table set.
Table.
Second window. And just set the independent for ask, and then that means you can type in what you want. Make sure that dependent is still on auto. Okay, if you don't know how to do that, it's not a big deal. Just plug it in for x. Let me show you. 6 times -1/2 cubed minus 29, that's what your calculator's doing, times -1/2 squared minus 6 times -1/2 plus 5. Oops, I forgot my 1. And I get a 0. Okay? That's what your calculator's doing. It's just a faster way to use what's already in your y equals. Any guesses on what that last one was? You think it's a 1/3? Did you check already? Yes. 1/3 is also a 0. Okay. So then, using the graph from Part B to get you started, find the zeros algebraically using synthetic division and or factoring. So what I mean by that is, if I wanted to factor these, I'll start with my nice 5. So I just am dividing out that 5 now. And notice I get a remainder of 0. I was correct, right? I'm going to write my factor down, x minus 5. What do you guys want to try next? -1/2? What's 6 times -1/2? -3. This would be positive 3/2. No. I'm getting ahead of myself. This would be -2. -1/2 times -2 is positive 1. Okay. Nope. The factor it is the 0. Okay? So since we have the zeros, they're the same, okay? The zeros are the same. The factor is the opposite, because if I put a 5 in here, that would make it 0. Okay? So we confirmed that this one was, but it's not appropriate to write a fraction factor like this. Does anybody remember how we write this? Good. 2x plus 1, if you would multiply through by the denominator, okay, which is a 2, and think about it. Doesn't negative 1/2 make this 0? Okay. And then I'm left with 6x minus 2. That's what this would be. Except 6x minus 2 I could leave it that way, but technically I could take out a 2, couldn't I? Okay. So I'm going to take that 2 out to the front, which would leave me with 3x minus 1. Okay, so were we right about our zeros? But to confirm algebraically, the synthetic division should give you a remainder of zeros. You were not asked to do this, but this is what the function would be in factored form.